and welcome back. Let's take a look at what's going on in week 5. This week is going to be all about solving inequalities. Section 310 is polynomial inequalities and section 311 is rational inequalities. In 310, each video, there are 5 of them, is just a short example, and I suggest you watch them all. When you solve, so they're just two, in videos 1 and 2, they're a couple of short examples of how to show your number line and give your answer in both inequality notation and interval notation. In video 3, you'll see these general guidelines for solving a polynomial inequality, plus that example requires you to factor by grouping, which is great practice. So in general, when you solve an inequality, either polynomial or rational, you're going to be breaking up your number line into subintervals, and then you'll be testing each subinterval to see if the inequality is true or not. And again, he's going to go through these steps with you in video 3. Also in video 4 and 5, he'll talk about those steps again. Videos 4 and 5 are just different types of factoring out the GCF, and then another one of factoring a trinomial. This is really an important section because the next section piggybacks on this section. So the next section is this section on steroids where we talk about rational inequalities. So now remember, rational function is one that's a quotient of polynomials. So you'll be solving things like this. And video 1 is an overview lesson. So it's like about 12 minutes. And it just gives you an overview of what you're going to be doing. And there are 2 great examples. One talks about less than or equal to, and one has strictly less than, and you'll see the differences that those create in your answer. Pay special attention to videos 5 and 6. This is video 6 here, where he solves a more difficult rational inequality. Now, one thing you might be asking is, as you go through his video solution, you might say, hey, why not just rather than move the 2 over and get a common denominator, why can't I just multiply both sides by x plus 2 and clear the denominators? So you'd have x plus 5 greater than negative 2 times x plus 2, and then you're in the situation of a polynomial inequality. Well, the reason you can't do that is that you can never multiply both sides of an inequality by an expression with a variable in it if you don't know that expression is positive or negative. So if this were a positive expression, the inequality would stay in the same direction. But if this were a negative expression, the inequality would flip. And so that's why you can't do that. Never, ever multiply both sides of an inequality by a variable. It's kind of dangerous. Just follow his instructions. Move everything to one side and get this greater than 0, and then go on from there. And it's going to be very important that you show your work on the next test. So I'm going to want to see your number line set out with your subintervals, and I'm going to want to see you testing each subinterval. Okay, and that's the end of this